In section 5 of this course, we're going to be taking a look at more advanced game mechanics. Specifically, we'll see the many different ways in which we can make objects move, both on their own and according to player controls, and how we can make objects rotate. In doing this, we'll see concepts like vectors, pivots, and quaternions. In this video, we're going to take a look at character pivots and how we can make them move using vectors. Specifically, we'll also see frame independence, that is, how we can make the movement of the character independent from the frame rate of the game. In this video, I want to consider the fundamentals of movement and motion using vectors for objects inside 3D space. The project that I have open here in front of me is the Motion and Rotation project that is included in the course companion files. This pretty much consists of a simple scene in which we have a plane object representing the floor of the level, and we also have the Ethan character that is included in the native Unity characters package. So this is a pretty simple model of a game character, but notice that when I select this character here, I'm going to move down here to the project panel. I'm going to right click, choose create, choose C# script, and then I'll call this mover and press enter on the keyboard and drag and drop the mover script onto the Ethan character. If I select the Ethan character here and see the mover script inside the object inspector, I'm going to open that inside MonoDevelop by double clicking the script file. And here we have the mover script available to us. Now, of course, if an object is moving forwards or moving at all, whether forwards, backwards, left, or right, it's going to be moving at a particular speed. And this is going to be represented in terms of meters per second, and that is a decimal value. So I need to create a speed variable to accommodate that. So I'm going to choose public, float, and speed, and I'll set the initial speed to 1 meter per second. The next thing that I want to keep track of is, of course, the transform component, because the transform component is what encodes the actual position, rotation, and scale of an object. To get access to that information, I need to get access to the transform component. So I'm going to create a variable called this transform just to get the transform component to the object. Now, because this is a private variable, it's not available from the object inspector. But of course, I can retrieve a reference to the transform component inside the awake function here. That is called when the level begins. So I can get access to the transform component there. So that's pretty much all we need to make this object move at a consistent speed. Let's take a look at how we do that inside the update function. So effectively inside the update function, we want to update the character's speed. To do this, I'm going to choose the transform component here and then choose position. And of course, I'm going to choose plus equals because I want to accumulate onto that position. That is, I want the character's position to be what it is right now, plus an additional amount of displacement. Now, the displacement is going to be represented by a vector. So it's going to be the position of the character here. And of course, we have our displacement. Now, the displacement is going to be based on the forward vector. That is, we're taking the direction in which the character is looking in world space, the forward vector. And the forward vector is by default a unit vector. That means it only represents direction, which is why I can multiply it by our speed to scale the vector and represent the displacement according to our speed. Now, right now, if I leave this as it's written right now, then the speed variable is actually based on the frame rate of the computer. But what I can do instead is multiply that by Time.deltaTime to scale the speed value to be consistent over time. So we have the variable here, which is Transform.position, and then we're updating that position over time. I'm going to press Command S on the keyboard to save that value and then return back to Unity. That will go ahead and compile. And there we are. All the changes are compiled. If I select the Ethan character inside the hierarchy panel, you can see that the mover script is attached. The speed variable is assigned here. By default, we've assigned it the value of 1. I don't know if that's okay. That really is going to be something we're going to need to test here. So I'm going to press the play button on the toolbar And straight away when I do this, the character suddenly leaps into motion and is moving forwards. We can still test out that it's moving along that forward vector, because if I choose to switch to the rotate tool, then during gameplay, if I rotate the character, it continues actually moving in the direction in which the character is looking. So that's looking pretty good, but what I actually want to do next up is to actually link the motion of this character based on keyboard input. That is up and down and left and right. I want to be able to move the character forwards, backwards, and to turn to face a completely new direction. We'll see how to do that